Assalamu alaikum. Today, inshallah, I'm going to explain the stretching of a spring or Hooke's law. تعالوا نبدأ كده بالclassification of materials. We can classify the materials into two categories. We have springy materials and less springy materials. Springy materials are called elastic material. Let's see the difference between these two types. We have materials when the force is applied on springy materials, they deform. When the force is removed, they return back to the original shape. Yani, when we apply a force on an object, the shape of the object changes. And when this force is removed, the object returns to the original shape once again. On kicking a ball, you see the shape of the ball is deformed for an instant of time. When your leg touches the ball, the shape is deformed. When you leave it, the shape returns to the original shape once again. This is what is meant by springy material. But less springy material, احنا بنسميها plastic material. Why? Because when the force is removed, it will not return to the original shape again. So this is the main difference between springy material and less springy material. Springy material is elastic material, and less springy material is plastic material. Or we can say that springy material بيحصل لها elastic deformation. Elastic deformation, يعني when the force is removed, it will return again to the original shape. And elastic deformation, when the force which causes the formation is removed, it will not get back to the original shape. Okay, so here we consider the springy material like a spring. Here, this is a spring. This spring has length L naught. When we hang a load in the spring, it's stretched, right? So let's see the difference in length. Here, as you see, this distance is known as extension. While from here to here is the original length, from here to here, it is the total length. So we have the new length equals the original length plus the extension, which is x. Okay, this x or the extension is caused because of the force or the load, because we hang a load here. Okay, what happens if we add another load? We double the load. If this load is 1 Newton, so here we double the load. Let it be 2 Newton. You will find that the extension will increase, but here it will increase by double. If the extension here was x, here was x, so the extension here will be 2x. If we increase the force to be 3 Newton, so you will see that the extension increases 3 times than the original one here. So this extension will be 3x. So here we have a direct relationship between the applied force and the extension. Okay, and this is Hooke's law. Hooke's law states that the force is directly proportional to the extension. So to change this form into equation, this sign it is a sign of directly proportional. لما نشيل الساين بتاع directly proportional, we replace it by two things. يبقى constant and equal, this is replaced, أو this is replacing the directly proportional sign. هنشيل directly proportional sign, يبقى F بتاعتك equal KX. Okay, تعالوا نعرف بقى where F is the load or the force, the applied force, and X is the extension, and K is the spring's constant. Let's see this reading here. We have here a spring. When the load is 0, the length is 24 centimeter, and there is no extension because there is no load. So here you have to know that this 24 centimeter is the original length. Okay, when a load of 1 Newton is added, the length becomes 24.6. So here, as you see, there is an extension. What is the value of extension? The extension, we can get the value of extension by get the difference between the new reading or the new length and the original length. So as you see, 24.6 minus 24, we get 4.6. Okay, so increase the load to be 2 Newton. So we can find the new length becomes 25 the 25.2. So we get the difference between this and this. We find it is 1.2. So here, as you see, 1.2 is double 0.6. That double that. Because the load is double. Okay. So and so on. As you see, the load increased by 3, 4, 5, and so on. Each time the length increases by 0.6 and the extension increases by 0.6. Okay. طيب. What's the difference between this reading and this reading? Here, the difference between 0 and 0.6 is 0.6. Between 0.6 and 1.2 is 0.6. And so on. The difference here is 0.6. And here it is 0.6. 0.6. And so, okay, so, and here it is also 0.6. But between 3.6 and 3.4, the difference here is 1. Okay, although the increase in the load is the same. يعني each time the load is increased by 1. لكن هنا كده اللي حصل extension is not 0.6. What happened here? احنا قلنا ان there is a direct relation between the load and the extension. So the direct relation is always represented as a straight line passing through the origin. طيب. At this point, عند البوينت دي كده حصل broken line. ده معناه ايه? This means that the relation between the load and the extension is no longer directly proportional. Why? Because this point is called limit of proportionality. يعني ايه؟ يعني before 6 Newton, the extension and the load are direct proportional to each other. لكن after 6, they are not direct proportional to each other, as you see here. So this value is the limit of proportionality. Okay. طيب. Before the limit of proportionality, the material obeys Hooke's law. What does this mean? يعني obeys Hooke's law معناها and as the force increases, the extension increases. If the force or the load increased by double, the extension increased also by double. Okay, this is what's meant by Hooke's law. Hooke's law states that the extension of a spring is directly proportional to the applied force, provided that the limit of proportionality is not exceeded. So F equal Kx. If we want to draw the relation between the load and the extension, so we have to draw a straight line like this. And after this point, the line takes this shape. This means that you exceed the proportionality limit. Okay, طيب. Look here. If you are at this point, تعالوا نشوف مثلا تعالوا نقول ان اللود هنا let's say it is 5 Newton. Okay, and the load here it is 9 Newton. Okay, if you remove the 5 Newton from the spring will return to the original length once again. But here, if you remove the 9 Newton from the spring, it will not return to the original length once again. And take here a point here, which is here, let's say it is 11 Newton. If you remove this force from the spring, it will not return again to the original length. So here, if we remove the force of 11 Newton, it will not return back to the original shape. Okay, طيب. طبعا we know that any graph, you have to find the gradient. So the gradient here, it is delta y over delta x. So on the y-axis, the y-axis represents the extension and the x-axis represents the applied force. So as you see here, delta y is x over force. So what does F over force represent? We know that F equal Kx, and this is Hooke's law. So what is x divided by F? So here we divide here over F, and here divide over F. F over F equal 1. 1 equal K x over F. We need x over F, so x over F will equal 1 over K. Okay, so here this equal 1 over K. So here, if you calculate the gradient, yani is how to calculate the gradient. We select 2 points and get here, this is y1 and here is x1. By the same way, take another point here and take this point to be y2 and this is to be x2 and this is y 2, get the difference, y2 minus y1 over x2 minus x1, you can get 1 over k, not k. Why? Because here the extension and here the applied force. Okay, but if the relationship between the extension and the load, like this, here is the load, and here is the extension. Also, you will get straight line at the beginning, which obeys Hooke's law. The gradient for this line, gradient here, equal delta y over delta x. So delta y is the load, which is a force, divided delta x, which is the extension. So f over x from Hooke's law, f equal kx. If we divide f over x here, you can get, this is over x, x cancelled with x. So f over x will equal to k. So the gradient here, if you calculate the gradient, you will get the value of a. So the gradient here equal k. While لو عكسنا بقى جبنا هنا الاكستنشن وهنا اللود هيبقى 1 over k. Okay. طيب. Here's this graph here. This is a elastic region or linear region. This part. This is the limit of proportionality. After this limit of proportionality, there is no linear relation between the force and the extension. Sometimes you have relationship between the load and the extension. Like here, we can here plus here. This is the load. Here is the extension, and here is the load. Okay. Another graph is between the load and the length. I will show you what is the difference here. When there is no load applied on the spring, the length of the spring is the original length. And the extension is 0. So this is the original length. There is no extension, or the extension equal to 0. So when there is no load, the extension is 0. We have start from 0. So the relationship start from this point and go in this direction. Right. What if we make the relationship between length and load? In this case, this is the original length of the spring. When we applied a load, the spring is stretched, okay? And this part is L node, and this part is extension. There is here, this is L node, and this is the extension. And this plus this equal the length. So at this point, the load is 0. When the load is 0, there is no extension. No extension means the length, the total length is the original length of the spring. يبقى here this case, when the load or the force equal 0, no extension. So the total length will be the original length. In this case, no load, so you can't start from 0. Because انت هنا بتعمل relation ما بين اللود والlength. So the length here is the original length, it's not 0. عشان احنا هنا بنعمل relation between the load and the extension. The extension here, no load, no extension, started from 0. لكن احنا هنا relation between the load and the length. When there is no load, the length is the original length. Okay? يعني هنا اقول لك كده if L equal L node plus X. Okay? No load, if F equal 0, يبقى X كمان equal 0. So L equals L node plus 0. يعني L بتاعتك equal L node. Okay? فأنت لما تلاقي جراف بالمنظر دوت, this reading is the original length. This is L node. طبعا الجريدينت هنا هيكون equal 1 over K برضه. Okay? Let's get back to the file. Okay, let's talk about the energy inside the spring. When the spring is stretched, it stores energy called elastic potential energy. When the spring is compressed, It also stores an elastic potential energy. يعني احنا مش عندنا how to calculate the value of elastic potential energy، بس لو عايزين نعرف ازاي بنحسبها. Elastic potential energy equal half kx squared. This is the elastic potential energy stored in the spring. Let's solve this question. An experiment is carried out to measure the extension of a rubber band for different loads. The results are shown below. Here we have the load, the length, and the extension. When the load is 0, the length is 15.2 and the extension is 0. So when you find the load is 0, you should know that this length is the original length. This is L0. Okay, so which figure is missing from the table? عايز الريدنج اللي انا هكون كده. Okay, فتعالوا نشوف هنا الجبن عندي. Load is 2 Newton and B extension is 2.1. What is the length? The length L is the L node plus the extension. So the L node is 15.2 and the extension is given as 2.1. So when we add this together, you get 17.3. This is correct answer. Question 2. The extension load graph for a spring is shown. The stretched length of the spring is 17 centimeters. Okay, this is the original length. This is L node equals 17 centimeters. When an object is hung from the spring, the length of the spring is 19.2 centimeters. So the length L is 19.2. You have here L node and L. What is the weight of the object? طبعا عندك ال L وال L node, you can get the difference between them عشان نجيب ال extension equal كام. So the extension equal 19.2 minus 17, it is 1.2. So the extension is 1.2. هو عايز اللود equal كام؟ فأنا لازم أعرف الاكستنشن بتاع اللود ده كام. الاكستنشن بتاع اللود اللي هو حاطه دوت 1.2. بعد كده أرجع للجراف بتاعي أدور على extension 1.2. فأنا عندي هنا الاكستنشن here 1 2.1 here. Here's 1.2, 1.4, yes, this is 1.2. So here we get the extension here of 1.2 to cut the line at the point and then connect this point here. We can take this reading. You'll find it to be, this is 1, 2, 3, 4. This is 1.2, 1.4, 1.6. Okay, so the correct answer here is 1.6. Let's have another question. Two metal blocks P and Q have identical dimensions. They hang on identical spring. Okay, this is P and Q. As you see here, Q has the weight of Q greater than the weight of P. Okay, what is the question? What can be deduced about P and Q? Okay. They have different volumes. لا هو فوق هنا قايل لي ان هو identical dimension، يعني ايه؟ they have the same length, weight and height، يبقى they have the same volume. فاحنا هنشوف كده look at equal volume عندي C and D. طيب they have equal weights؟ طبعا لا، هنا في الجراف هنا this is 3 نيوتن and this is 2 نيوتن، يبقى they have different weights. ايوه بس دي هو مش جايب لي different weight، هو different masses. ما هي different masses هي also different weight، لأن الويت بتاعنا الويت equal m times g. الويت ده مش هيختلف إلا لو الماس اختلفت، لأن الجي constant equal 10. هيبقى الويت بتاعي they have equal volume and different masses. Let's have another question. The diagram shows a steel spring and the graph of its length against the load applied to it. قلنا الجراف لما يجي بالمنظر ده كده، وهنا اللينس وهنا السبرينج, this reading is the original length. This is L node. So the original length of the spring here is 5 centimeters. Okay, طيب تعالوا نشوف what is the question هنا. Okay, what is the extension of the spring when a load of 20 Newton is applied? What is the extension when the load of 20 Newton? طيب تعالوا نشوف بقى، هنيجي عند اللود of 20 نيوتن اهوت. When we apply a load of 20 Newton, the length, okay, not the extension, is 8 centimeters. So L equal 8 centimeters. So you have L and L node. He asks you to find B extension X. So which is L minus L node, which is 8 minus 5 equals 3 centimeters. Okay, let's have another question here. A student adds weight to an elastic cord. He measures the length of a cord for each weight. He then plots a graph and the result as shown. Okay, the graph here عندي هنا weight. Weight here means the load or the force. Okay, what should be written here? طبعا because it starts from zero فلازم نكتب هنا an extension. Okay, but as you see here for the answers here measured length, original length ما عنديش extension هنا. بس عندي أنا أعرف I know that the extension equal the length minus the original length. So like here the measured length minus the original. So its answer will be D. Objects with different masses are hung on a spring. The diagram shows how much the spring stretches. As you see here in the diagram, this is the original length. This is N. And here we add the weight of 100 grams, so the extension becomes 20 centimeters. So the length becomes 20 centimeters. And we hang a mass M, so the extension becomes, so the length becomes 30 centimeters. What is the value of M? Okay, now there is a linear relationship between the force and the extension. So 100 gram عملت لي extension ب 10 centimeter. This M عملت لي extension ب 20 centimeter because here is 10. Okay, the extension of the spring directly proportional to the mass hung on it. What is the mass of the ring here? So when the mass is 100, extension was 10. What is the value of mass which causes the spring to be 20 centimeters? Of course, it should be 200 جرام. عشان احنا قلنا لما اللود بيحصل دبلنج الاكستنشن كمان بيحصل دبلنج. بالفعل الاكستنشن هنا كان 10 اصبح 20 فال 100 جرام هتبقى هنا 200 جرام.